Hello everybody, Sorlian here, and today we are looking at solving simultaneous equations using the method of substitution. And at the end of this video, you should be able to do exactly that, solve simultaneous equations using the method of substitution. So let's head straight into the contents of this video. So when solving simultaneous equations, we aim to find the values for the variables that satisfy both equations simultaneously. And by simultaneously, we mean the same time. So whenever we find the values for the unknown and we put it into the equations, they all should satisfy the equations. So in CXC, you are given two equation maximum with two unknowns. And probably when you move on later on in your studies, you'll have three equations with three unknowns and so on. So there are many ways we can solve simultaneous equations, but in this video, we'll be exploring the substitution method. So the aim of substitution is to put one of the equations into the other equation. In that way, you're combining both and you can turn it into one equation and then you can solve from there. So how do we decide which equation to put in what? So an easy way to think about it is if you have in either of the equations, you have a variable by itself, but we know it's not really by itself, there's a 1 in front. But when you see a variable by itself, you make that variable the subject and then you put that equation into the other one that you did not use as yet. So this is a mouthful, so let's see how we can put this into practice by working this example. So this question says, solve the following system of equations. And we have x plus y is equal to 10 and 2x minus y is equal to 4. We're asked to solve this. So for this, what we can do, we can start off labeling them. So we can call this top one equation 1. We can call this bottom one equation 2. So what we want to do, we want to put one equation into the other. So we see in equation 1, we have x plus y is equal to 10. So we see both x and y there by themselves. So what we can do, we can either make x or y the subject. So the easier one to make the subject would be the x. So we take over the y. So we have x is equal to 10 and the plus y goes over to become minus y. We can call this equation 3. So we basically use this equation to make x the subject. So what we do now, we take equation 3 and we put it into the other one that we did not use as yet. So we're replacing x. So instead of 2 times x, we'll have 2 multiplied by 10 minus y is equal to 4. So we distribute the 2. So we'll have 2 times 10 is 20. And 2 times negative y would be negative 2y minus y is equal to 4. So now we see we just have y alone by itself. Y is the only variable there. And that was the aim of doing the substitution, so that you're left with one variable. So when you have one variable now, you can go ahead and solve that. So we do some simplification and we solve. So we work out here, negative 2y minus y would give me 20 minus 3y, and that would be equal to 4. So now we can solve here. So this is a plus 20, when we take it off, it will become minus. So we'll have negative 3y is equal to 4 minus 20. So negative 3y is equal to 4 minus 20 would give us negative 16. So now we solve here. So we want to solve for y. So we have the negative 3 multiplying the y. So when we take it over, it will divide. So we'll have y is equal to negative 16 all divided by negative 3. And this negative will cancel out that negative. So we say y is equal to 16 over 3. And that would be the value of y. So now that we have our value for y, now we can solve for x. So how do we solve for x? We solve for x by putting in this value of y into either equation 1, 2, or 3. So we see equation 3, x is already the subject. So we can solve for x there. So x will be equal to 10 minus y. Now instead of y, we'll substitute y equals 16 over 3 into equation 3. So 10 minus y would become 10 minus 16 over 3. And if we punch that in our calculator, we'll have x is equal to 14 over 3. And that is what would be our value for x. So we have x is equal to 14 over 3 and y is equal to 16 over 3. So now that we have our answers for x and y, now we can put in these two answers into either equation 1 or 2 to check to make sure our answer is correct. So it's nice to put it into both to make sure that both equations are satisfied. So let's see, let's use equation 1. So instead of x plus y is equal to 10, we know x is equal to 14 over 3 plus y, which is 16 over 3, should be equal to 10. So the denominators are the same, so 14 plus 16 will give you 30 over 3 is equal to 10. 30 divided by 3 is 10 is equal to 10, so that checks out for equation 1. So let's check equation 2. So equation 2 is 2x minus y is equal to 4. So it will be 2 multiplied by x, which is 14 over 3, subtract y, which is 16 over 3, should be equal to 4. So 2 times 14 over 3 will give you 28 over 3, minus 16 over 3 should be equal to 4. So 28 minus 16 would give you 12 over 3 is equal to 4. And 12 divided by 3 is 4. So 4 is equal to 4. So that checks out as well. So we know our answers that we got, they were correct. And we know we will get all of the marks in this question if this question comes. So we work it out, we get our answers, and then we put it back in to check to make sure what we got was correct. And as long as both sides of the equations are satisfied, we know what we did was absolutely correct. So let's do another example. So this example says, solve the following system of equations. So we have 3x plus 2y is equal to 12 and x minus y is equal to 1. We are asked to solve this. So of course we see x by itself. So what we do, we first label, so let's call this equation 1. And let's call this one equation 2. So we see x is by itself, so and y as well. So but we can make x a subject by taking over this minus y. So we'll have x is equal to 1 plus y. We can call this equation 3. So we already use this equation to make x a subject. So what we do, we take this answer and we put it in the other equation. We cannot put it in the same equation because that means you will not be involved in both equations into the solution. So we solve. So we'll have 3x. So we can say we substitute x equal 1 plus y in equation 1. So you don't need to write this, but I'm just putting this as an extra guide for you. So we'll have 3x. Now instead of 3 multiplied by x, we'll have 3 multiplied by 1 plus y, and that is the value of x that we have, plus 2y is equal to 12. And we do some simplification and solve. So we distribute this 3. So 3 times 1 would be 3. And 3 times y would be plus 3y plus 2y is equal to 12. And we simplify. 3y plus 2y would give us 5y, and this will be added to 3, is equal to 12. So we solve from here. So we see the 12 is adding, so we take it over to subtract. So 5y will be equal to 12 subtract 3, we will get 9. So to solve for y now, the 5 is multiplying the y, so we take it over, we will have y is equal to 9 divided by 5. Hence y is equal to 9 divided by 5 will give us 1.8. We could leave it as 9 over 5, but since 1.8 is just the one decimal place, we'll use that. So we have our value for y. Now that we have our value for y, we know the next step is to get our value for x. So what we do, we substitute y equal 1.8 into, you can either use equation 1, 2, or 3. So of course, we see the easiest equation to use would be equation 3 because x is already the subject. So you can say equation 3. So we'll have x is equal to 1 plus, instead of y, we say 1.8. So x will be equal to 1 plus 1.8 will give us 2.8. And that will be our value for x. So we can say, therefore, x is equal to 2.8 and y is equal to 1.8. So now we can do the nice part, which is to check to make sure that what we did was correct. So what we can do, we can substitute both of these into both equations. So let's see. So let's use equation 1. So we say 3, instead of x, we'll say 3 times 2.8 plus 2 times 1.8. That should give you 12. So 3 times 2.8 will give us 8.4 plus 2 times 1.8. That will give us 3.6 and that should equal to 12. So 8.4 plus 3.6 will give us 12. So 12 is equal to 12. So that checks out. So now we can check for the other one. So we'll have x minus y is equal to 1. So x is 2.8, subtract y, which is 1.8, and that should be equal to 1. So when we work this out, 2.8 subtract 1.8 will give us 1 is equal to 1. So that checks out and we know our answer is absolutely correct. We are in the cool to get all the marks. So let's explore this question. This one says use substitution to solve. So sometimes the question will just say you solve the equations below, solve the pair of simultaneous equations, or they may even specify and tell you which method to use. So we are asked to solve this. So we know the first thing we want to do, let's label it to give the equation some names. So this will be equation 1, and we know this will be equation 2. So we solve. So we have equation 1, equation 2. So the first thing we need to do, identify which variable is by itself to see if the substitution method is a nice and easy method to use. So we see we have x by itself here. So what we can do, we can make that x a subject. So we'll have x is equal to negative 2. And when we take over this minus 4y, we'll have plus 4y. We can call this equation 3. So we saw that we use equation 2 to make x a subject. So now we take this here now and involve the other equation by putting it into equation 1. So this will be 2 multiplied by x, which would be negative 2 plus 4y plus 3y is equal to 13. So 2 times negative 2 would give us negative 4. And 2 times plus 4y would give us plus 8y plus 3y is equal to 13. So we simplify. So 8y plus 3y would give us 11y, which is equal to, so this is a minus 4. When we take it off, it will become 13 plus 4. So 11y is equal to 13 plus 4 would give us 17. So hence y is equal to, this 11 is multiplying this y. When we take it off, it will divide. So you'll have 17 divided by 11. And we know if we divide this, we'll have a very long decimal. So we can leave this just as it is, so that when we want to check our answer, we'll be able to verify, rather than putting it as a decimal and then rounding off, and we'll get a slight difference. So we have y is equal to that. So now that we have our value for y, we can now find our value for x. So we can substitute. So we can substitute y equals 17 over 11 into, and we see the best one to do is equation 3. Equation 3. So we'll have x is equal to negative 2 plus 4y. Instead of y, we'll have 17 over 11. So x is equal to negative 2 plus, now 4 times 17 will give us 68 over 11. So a negative 2 plus 68 over 11 would give us x is equal to 46 over 11. So we have our value for x and we have our value for y. So we can say therefore x is equal to 46 over 11 and y is equal to 17 over 11. Of course, we don't want to take it for granted, we want to check. So let's check it. You want to check, especially when you have fractions as your answer and decimals. You want to check because most times CXC, not all the time, most times when they give you a question to work, It will be a nice and easy decimal, probably like 2.5 or something, or it will be a whole number as the answer for both x and y. Most times, not all the times, most times. But if they tell you to round off your answer and so on, you know that you're looking at the decimal of it. But if they don't tell you to round off, a hint is that your answer will be a whole number or a nice and easy decimal. So let's work it out. So let's substitute. So we have, instead of 2 times x, we'll say 2 times 46 over 11 plus 3 times 17 over 11 is equal to 13. So 2 times 46 will give us 92 over 11 plus 3 times 17 will give us 51 over 11, and that should be equal to 13. So 92 plus 51 would give us 143 over 11. That should be equal to 13. And 143 divided by 13 will give us 13 is equal to 13. So we know that checks out and our answer is correct. So now we can check it for the other equation. So instead of x minus 4y, we'll have 46 over 11 subtract 4 multiplied by 17 over 11, and that should give us negative 2. So we'll have 46 over 11 subtract 4 times 17 will give us 68 over 11, and that should be equal to negative 2. So 46 subtract 68 will give us negative 22 over 11, and that should be equal to negative 2. So negative 22 divided by 11 will give us a negative 2 is equal to negative 2. So that checks out, so we know our answer that we got initially, it's 100%, and we got all of our marks. And that is how you check. So now that we have a firm understanding of how to utilize this substitution method to solve simultaneous equations, I will leave these 2 questions for you to practice. So we have 2 questions here for you to try on your own and see how you will make it with substitution method. So until then, take care, and I'll see you in the next video.